Hello, everybody. Let's just start with a super quick show of hands. So, who here works with GraphQL at the moment? So, a very, very small percentage of you. Of you guys, who knows what semantic not null means? In other words, who of you are federating your GraphQL and distributing your schemas? Just one. Don't worry, okay? You're going to have to explain it to me later. You know, I always thought I was quite technical, and I recently joined WunderGraph, met my colleagues there who actually implement federation. Whew, like straight over my head, seriously. But don't worry, I'm not going to go that deep. How many of you are experimenting with MCP? And how many of you have built MCP servers and got those up in production? So, cool. So we've got a good mix, and it looks like we've got folks from all stages of their API journey. That's perfect. And today I want to kind of join the dots between GraphQL and MCP. So there'll be something valuable for everyone here, no matter where you're starting from. My name is Ahmet Soormally. I work for WunderGraph. I'm Principal Solutions Engineer. We do open source GraphQL Federation, Apache 2. I like to bake sourdough. I'm a proud dad of a 4-year-old, and she keeps me balanced. She teaches me that there's far more to life than my IDE. And so with that, let's just dive in. We'll start with a quick tour of how MCP fits into the bigger picture of modern API architectures, and then we can dig into what I think could be a huge win for GraphQL as a technology. So when I first started reading about MCP, I saw it described as USB-C for models. And honestly, I thought, I love LAMP. But then it clicked. Large language models are trained on huge data sets. They're static snapshots of the world. They're amazing at recognizing patterns, generating text, but you can't actually, they can't interact with the world around them. They don't know what's happening right now, they can't fetch a live metric, and they definitely cannot call your API. At the end of the day, the LLM is just a pattern matcher. It learns statistical relationships in text and predicts what comes next. But when you pair that pattern matcher with live data, real-time context, the ability to call an API, magic happens. It can start to infer, analyze, and act. And not just repeat patterns. So early attempts to make that happen used function calls. But the problem is that every model provider did this differently. And that's where MCP from Anthropic comes in. It's quickly emerging as the standard way for tools and data for models to talk to tools and to data sources. The universal connector, or the USB, for models. So I'm convinced. I need USB for my models. I've got a ton of data inside my organization. I want people to be able to talk to my data in my organization. I'm going to make it available to the LLM. Let's take all our microservices and MCP our REST APIs. Not so fast, Sonny. Your REST API was never originally designed for consumption by an LLM. When we MCP the REST API, every microservice endpoint becomes a tool. And you're not going to have 10 tools. You're going to likely have hundreds or thousands. Have you ever been to a restaurant with a huge menu? You end up with decision paralysis, deciding what you want to eat. And models don't browse menus well either. More tools mean longer descriptions in the prompt and give the model far more to reason about. Performance drops when you go above 30 tools. There have been studies that prove this. And the model hesitates. It might pick suboptimal calls. Sorry. and it might yeah, so performance drops when you go above 30 tools. And it might pick suboptimal calls. It's going to burn through your tokens like nobody's business, just on tool selection, not the actual task at hand. LLMs are not workflow engines. Real answers, they require sequences, authentication, accounts, billing, usage, and then somehow combining those all together. And they can probably call a couple of functions reliably, but then changing 5 to 10, or chaining 5 to 10 endpoints is brittle, non-deterministic, and things might be executed in the wrong order. What about error handling? If any one of those chained calls fails, the model might end up inventing recovery logic that it was never ever trained on. REST APIs, they often overfetch. The model gets 40 fields, it only actually needs or cares about 5. Every extra field inflates the prompt. It crowds out instructions and increases the risks of hallucinations. And you pay tokens to describe tools, and you pay tokens to show big responses, and also tokens to reason about noise. So as an example, you asking a model about model risk for a customer, this shouldn't require shipping full invoice line items. You're just going to end up bloating the context window. And exposing every endpoint means exposing every mistake with undervalidated inputs, n+1 patterns, and an LLM doesn't know how expensive or heavy an API call is. They don't know which queries will trigger a large database join, aggregation or nested service call. So if the model generates a harmless looking API request or tool call, it might actually be computationally huge. It can touch sensitive data and even hammer endpoints in loops, and you've got effectively exposed your whole API surface to something that doesn't understand rate limits. And let's be honest with ourselves, governance has never been REST's strong suit. For many moons, we've promised to document, version, deprecate endpoints properly, but we still end up with zombie APIs, mystery, parameters, and Jira tickets saying, don't touch billing v1. And suddenly, just because AI showed up, we think we're going to nail governance? Come on, folks. We weren't doing REST well before AI. What makes us so sure that we're going to nail it now? And we're doubling down on it just because we have an LLM as a consumer in the mix. REST granularity and lack of unified schema make versioning, observability, and lifecycle management brutal at that level of enterprise sprawl. So yes, MCP is the USB for models, but dumping a REST surface into that USB hub will just make it overheat. What we want is the ability to curate task-level, typed, governed tools. So let's shift gears a bit. If REST isn't the best thing to plug straight into MCP, what is? GraphQL. GraphQL has been around since 2015. We've all heard the elevator pitch, flexible queries, typed schemas, and one endpoint to rule them all. But what's fascinating is how GraphQL is evolving again, and this time to meet AI's needs. We already know that typical REST to MCP wrappers, they dump everything, all fields, all metadata, into the model's context. That's like giving an LLM a buffet when it just wanted an espresso. And GraphQL fixes this with selection sets. You can say, give me only the name, the risk score, and the last invoice date, nothing else. And that's huge for AI context optimization. Every extra field costs tokens, and with GraphQL, the LLM or MCP tool gets only what it needs. No overfetching, no noise, just the job to be done. And here's the real power, because GraphQL has got strongly typed schema, like protocol buffers, but for the web, for example. Every type, field, and input is defined, validated, and versioned in the schema itself. And that means there's no drift between what's documented and what's actually in production, because the schema is the documentation. Descriptions and examples live right beside the fields that they describe. So when you introspect the graph, you're literally reading live executable documentation. And this typed self-documenting schema becomes a machine-readable contract shared by developers, services, and now LLMs. So with GraphQL, you get precision through selection sets, stability through typing, and trust through live documentation. And if we zoom out, because very few companies have a single service, most have dozens: billing, CRM, analytics, support, and they're all owned by different teams, but in different stacks and evolving at different speeds. A single schema for everything, that's completely unrealistic. And that's where federation comes in. It takes all those independent domain graphs and composes them into one supergraph, a unified type layer across your entire organization. And so with WunderGraph Cosmo, you can connect different data sources and unify them into that single stable schema. You can think of it like views in a relational database. You don't duplicate tables every time someone needs a new perspective. You create a view over that same data. Federation does the same thing, but across APIs. And here's the beauty, because as your service evolves, you add fields, you refactor types, you shift your models, and your federated graph, it just stays stable. Your contracts don't break, your queries don't drift, and your MCP tools just keep working. It becomes a live, typed index of your business. Always indexed, always consistent, always current. And federation is doing for AI what it already did for web and mobile apps. It collapses your backend for front-end sprawl. Instead of building 100 separate API wrappers for every agent or model, you expose a single federated graph and curate collections of operations from there. And this gives you a unified governance, consistent security, and shared observability, a schema that grows with your organization, not against it. What began as a developer convenience has evolved into providing the governance, the stability, and consistency that enterprises need to manage complex APIs at scale. So we've got our federated graph. Now what? In development, we actually want the LLM to help us to discover what's inside the graph. During dev, we can keep introspection enabled so that the model can explore the schema and understand available fields and even suggest useful operations. You can think of it as a co-pilot for your graph. So an LLM could explore the schema and say, hey, you often combine customer usage and support ticket. Shall I make a get customer health operation for that? Now, some of you might be thinking, this all sounds great in theory, but GraphQL in production? No chance. Outrageous, some of you might say. And you're not wrong to be cautious, because GraphQL can be a headache in production if you leave it wide open. It's hard to secure with standard API gateways. Without strict limits, you're vulnerable to like complexity or depth-based denial of service attacks. Access control depends on per field level. You just had the session with Katie earlier. So traditional ACL doesn't really fit cleanly. 200 is not always okay. So if you look in any of your observability tools, you know, everything looks fine. And let's be honest, security teams don't trust or get it. And these are all, I guess, fair points. But that's only true when you leave GraphQL open. When you curate and persist the operations, GraphQL becomes something completely different. It's no longer a wild query engine. It's now a typed RPC layer where every operation is predefined, reviewed, versioned, and enforced at the router. And security and observability then just works like any REST API. And I guess this is the heart of it, curation. Instead of exposing the entire graph, you can define a collection of operations, predefined queries and mutations that have specific jobs. They're versioned, reviewed, and enforced at the router. And in MCP, each persisted operation would map to a tool. Each one being a clear task-level endpoint the LLM can safely call. And because our MCP gateway automatically exposes those operations as MCP tools for you, you don't need to handcraft JSON schemas or glue code. The best part, it's not just safer, it's more efficient. We've already discussed how LLMs perform better when they've got fewer well-defined tools. So if we circle back on the original question, is GraphQL the right tool for the job? I think it can be, especially when we treat the graph as a shared foundation, not just a query language. The graph, particularly a federated graph, it can reach deep into your organization, and we can start with exploratory tasks, where agents help us to discover the graph and learn its shape, surfacing relationships and generating queries with intent. Each of those queries can then be documented directly into the schema using GraphQL comments, turning exploration into your living documentation. And from there, we identify the key jobs to be done, promote those queries to golden operations, and then save them as a collection of persisted operations. When the router loads those collections, they become available as an MCP server, stable, secure, and predictable. And the best part is that agents can assist at every stage. During discovery, by introspecting and proposing useful queries. During curation, by helping to group, version, and document your operations. And even during runtime, by choosing the right persisted operation for the right context. So that means you can be as automated or as hands-on as your operation needs, as your organization needs. And it lets agents accelerate that process while you stay in control. So if anybody wants to talk, reach out. We can catch up about what we're working on at WunderGraph, or even some tips and tricks on how to bake a cracking sourdough. Thank you very much.
Thank you, Ahmet.